everybody. Hope you all are having a good start to Saturday. How many people were here yesterday? A good number of people. So, all right, you having fun so far?
Yeah. Oh yeah.
My name is Pete Roth, and I'm a member of the LA Orange County Audio Society. I'm on the board, but I'm also a associate editor of ultraaudio.com, which is part of the Soundstage Network. And it's really my pleasure to have you all here today, as we're all going to learn from really three fantastic speaker designers who, unusual in the field, are all extremely competent engineers.
And we like each other.
Pardon me?
And we like each other.
And they like each other, yeah, there you go. So you're not going to hear any acrimonious, bitter finger pointing, that guy's a moron, all he does is he buys drivers out of the catalog and stuffs in the boxes.
Be careful, they'll all leave.
So my thought was, look, every time you open up Stereophile magazine, every time you open up the Absolute Sound, and you go to the websites, you see all kinds of ad copy about it's shockingly great, breakthrough, 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 right? I mean, how many times have you flipped through the pages and seen somebody saying that the best thing since sliced bread was just invented, and they're the only ones who have ever come up with it before, and here you go. So my question for our three panelists, who I'll introduce in a moment, is, for designing speakers in the 21st century, has there been any breakthroughs? Is any portion of the marketing hype real? And that's what we'll find out. And then we'll go beyond that to find out how they're applying the technology advancements that have been coming down the pipe into their designs and what that's allowed them to do. So, again, we have to my left, your right, is Richard Vandersteen of Vandersteen Audio, responsible for, what, 250,000 pair of, or not pair maybe, but 200.
Please stop counting.
Stop counting. It's sort of like McDonald's. They used to have the banner up there. Now they just say thousands or tens of thousands, hundreds of thousands served. So Richard Vandersteen is to my left, your right, and then to my immediate right is Andrew Jones, formerly of University, then of KEF, then of Harman International and their Infinity group, and now for the last decade plus at TAD, Technical Audio Devices, which is a division of Pioneer. And then to my far right, your far left, is Kevin Vakes. There you go. And hopefully I'm pronouncing, somebody asked me, how exactly do you pronounce
That's
Vakes?
perfect.
Okay, so Vakes, there we go. And Kevin is the head of Harman's luxury performance audio group. He was fundamentally involved with Harman's first foray into truly high performance kind of cutting edge speakers with the Revel brand, and now is responsible for Revel and for the JBL Synthesis platform, as well as Lexicon and Mark Levinson. Am I forgetting anything?
But actually, gentleman Dave Rogers runs the group.
Oh, okay.
Well,
I'll give him all the kudos. Someone else who runs the group is probably just a manager or someone with a business. I don't know. Those are my words, not Kevin's. So let me just kick it off, and we'll kind of run down the line a little bit like at least we'll start like a typewriter, and we can bounce back, but everybody can chime in. So it is my observation as a reviewer that there haven't been any magic bullets. But at the same time, there have been some truly some real advancements that are made, even though they may not be magic bullets across the board. All three of our designers focus primarily on dynamic driver loudspeakers, although JBL has some horn-loaded compression driver technology speakers. Richard, what do you think about advancements in the last 12, 13 years in the industry as a whole first?
Well, it's been mostly refinements of materials. In the last at least couple of decades, there's been the address of the room and the bass, and
say.
Yeah.
I mean, you're right. It's basically, it's down to the basic fundamental techniques of producing sound from the speakers when you're talking dynamic drivers as opposed to, let's say, electrostats. It's the basic technique is the same as when it started. It's all down to materials technology and learning how to use materials and understanding what you're doing in relationship, like to the cabinet, to the room, all the things that can influence it. And availability of materials is a crucial thing. Some materials either were not available in the early days or ungodly expensive to manufacture, so nobody could do it. As time goes by, you get more accessibility for those materials. So more recently, there's been a growing number of exotic materials being used in speakers. Not all of them only just been applied, but been reapplied in new ways, or at price levels you could never do before. And I think that's one of the things where we're headed is exotic materials that have sonic benefits. Can we get it to the manufacturing stage where they become more price effective?
Kevin?
I fundamentally agree with both of them. No surprise there. I guess I would focus a little more on the application of what we've learned through research, more than materials, because I don't see many cases where materials have been any sort of breakthrough, even over quite a long period, possible exception of tweeter diaphragms. But learning how to refine the fundamentals and as Richard said, paying more attention and understanding better the interaction with loudspeakers and rooms.
Great. So Richard, debuting with the Model 7 and now in your 5A Carbon, and if I understand correctly, coming down the pike in a version of the Quattro, you have the new driver cone that you worked on a long time. Can you just give us a couple minutes on what took so long to figure out, and what makes that cone so special?
Well, we've had pistonic drivers for a long time. We call them perfect piston. However, if you were wanting to use them with first order filters, we have not had suitable pistonic diaphragms. And so for the since '97, we've been working to try to get a driver that's pistonic enough in order to use first order slopes and not have to resort with and have to use steep filters. So this was quite a challenge because for mid-range, for instance, our first breakup mode is about 16K, and that wasn't easy, and it still is very expensive.
Andrew, you've been working since your days at CAF with concentric drivers. What was it about having an all beryllium concentric driver, not just the tweeter component, but also the mid-range, that solved problems that before then had been compromises with the concentric driver technology?
That's actually interesting because it got me into trouble when I was developing the driver, because you develop drivers commensurate with the materials you're using. So I developed the various concentric drivers, and then when I knew I wanted to do it for TAD, I had access, as you say, to beryllium. And so the code profiles I developed previously for concentric drivers were always a bit of a compromise between the optimum profile that I need as a cone and the optimum profile I need as a waveguide for the tweeter. But I'd come up with some compromise that seemed to work okay. So when I built my first tooling for the beryllium driver, I used that same profile and built the driver, and it performed horribly. I think, oh, I've spent all this money on tooling up this driver profile. I'm going to have to start all over again. And it touches on one of the future questions about programs for calculating performance of drivers before you actually ever build finite element analysis and boundary element analysis. And so I had to go back to the drawing board, but I wasn't going to just keep on tooling up new building diaphragms because it's very expensive to do that. So we had to go back to analysis to understand what was happening. And the first thing, well, it's supposed to be perfect piston, and yet I've got a big suck out of 2K. Where's that coming from? And that was through boundary element analysis. We found it was due to acoustic loading effects, not mechanical effects with the driver. So we did all this analysis and postulated that if I make a shallow cone, etc., it'll fix that. And it did. But what it now allowed me to do is separate out, because beryllium is such a good material in first-rate diaphragm, I could separate out the shape I needed to act as a good mid-range from what I needed as a waveguide, and come up with some work for both.
Got it. Kevin, why don't we talk about how, I mean, one of the things that's been impressive to me, especially at the last CES, was the new Performa 3 line, which, is that out now, or is it coming out? Is it just around the corner?
No, I'm late as usual.
It's late. Well, what,
Sales says September, I say December.
right, so what was interesting to me is hearing the prototypes was at the price points, how much performance there was. So it's kind of getting into the bringing the, so I guess my question is, how did the Performa 3 line piggyback on obviously the Performa line that came before, but also how was that influenced by the Ultima 2 line, where we saw a radical change in cabinet design and everything else from the Series 1 to the Series 2?
Well, it was really influenced more by Ultima than by the previous Performa series. We don't like to be held back by history. And I'm excited because the whole objective is give the best value, and we were able to do that to kind of an extreme, just by better learning where we can save money, and where that has the least impact on the final sound quality. The biggest difference between the Performa 3 models and what they could be if there was unlimited money is freedom from diffraction, which is expensive because it's no secret that cabinets are your biggest cost. Not very exotic, but that's the fact. And so, yeah, there's more diffraction, but we can keep a lot of the other same qualities as far as our usual focus on the far-off axis response being very, very similar to the direct sound, which is what's come out of research as being important to the listener in a normal room. So we can still do that, just not with as much refinement. But things that are evolutionary, like another generation of waveguide design, that at first when we made waveguides, and the whole point, if anyone doesn't know, of the waveguide is that you match the off-axis response of the tweeter and the mid-range throughout the crossover region, so that there's not a rapid change in that response off-axis, because you almost always have that sidewall reflection. And it's important that that sound be very similar to the direct sound, because your ear-brain mechanism integrates them because of the short time delay. So improvements like that couldn't possibly be revolutionary, but are important to getting good sound, are very helpful.
Great. So moving away from the drivers, as we talked about Andrew and Richard's drivers. Richard, what component parts outside of the drivers, or maybe within the drivers but beyond the cones, have you seen the most evolutionary advancement in the last, let's say the last 10 to 12 years? Well, it can even be in the cabinet, it can be in the crossovers, it can be anywhere.
I think continued reduction of both the internal diffraction within the drivers themselves, because that energy can eventually come back out of the box, and dealing with diffraction on the outside of the enclosure. And our challenge is just to apply all this stuff, to try to apply this new stuff to lower price products to get the cost of doing it down. difference. We have better capacitors today, and all of this, better resistors, all of this makes a difference.
Andrew, I mean, you have a unique challenge. I mean, I don't know how familiar everyone is, but, Richard, you make speakers that start in the hundreds of dollars. I don't know, like $900 or something like that, for the 1Cs. And then up to $50,000 for the Model 7. So $1,100. And then at Revel, and then also at the other Harman brands, I mean, you start from $100 or maybe below, and you go up to, I don't know, the Revel Salons. 2s are what, like $20,000. So those are pretty broad spectrums. And then Andrew, you have the challenge of your speakers. Well, your new value price speaker is what, about $30,000?
Yeah, entry-level speaker for DAB, I keep joking.
So how is that challenge though of trying to bring things down? And then also, I mean, you designed a $100 speaker for Pioneer. That I think it's a direct order from Pioneer's website, right? Isn't there one that's a direct order?
There is, and the others are through Best Buy.
Best Buy and stuff.
But it's interesting because things are never cost no more. Even at $80,000, you work to a cost target. You probably failed, that's why it's now 18 instead of what you originally said was going to be 16. Especially for the cheaper speakers, I have a project manager that raps me over the knuckles every time I try and spend it.
Excuse
I said that wrong. Spending a penny on English.
Could you close that door?
Thank you.
But it is a challenge at any price point to come up with a design. It's always within a cost constraint, and it's where you spend the money. And once you've used it up on the exotic materials, how are you going to optimize everything else? And you mentioned cabinets, and that's an important part of that speaker. You always have to have good drivers. Good drivers in a poor cabinet is a poor speaker. Poor drivers in a good cabinet is a poor speaker. So it's getting the compromises, because there's always compromises involved. And with cabinets, especially as you come down in price, an expensive cabinet can almost cost no object in construction. But as you come down in price, you've got to give up on something. Can you use other techniques to work around the limitations of the cabinet? And so that's what I've done with these speakers, even with the reference one, where the cabinet is stiff enough, you bolt the drivers directly into the cabinet. And it's all about resonance control. At the frequency where that cabinet would start its first resonance mode, you roll off the driver and go to the next driver, but now this driver is decoupled from the cabinet. And so it's not feeding the energy in, because the major form of excitation of the cabinet, of the panel resonances, is not the acoustic coupling from the back of the speaker, it's the mechanical forces. The cone moves one way, just like a rifle, the bullet moves one way, the rifle butt moves backwards with equal force. Same with the magnet, that energy is fed through the cabinet. And so we deal with it in two different ways. You can't decouple the bass driver down to 20 hertz effectively, so you bolt it in stiffly, and then the next driver. So you decouple. So that's how I deal with that.
Right. There aren't many speaker manufacturers though that actually decouple their mid-range and tweeter drivers, are there?
No, I mean, I first started doing that at KEF, and then BMW did a tweeter on 4 springs. Not so I'm tweeter, but there's been some people do it, but yeah, it's not everybody who does that.
Kevin, why don't we talk about, I mean, just because we're talking about speaker design, you've already mentioned the research on listening that you do. And it's a pretty fundamental component of Harman's approach. And there are a group of other speaker manufacturers who are kind of seem like they're ringed up in Canada around the National Research Council or the NRC facilities where they do a lot of listening tests. Also, why don't you tell the audience a little bit about how the evolution of the listening reference room that you have at Harman and how that influences these compromises in the balancing act that both Richard and Andrew talked about.
Okay, great. We do listening tests that clearly are derived from the work that Dr. Toole did at the National Research Council in Ottawa, where the Canadian government finances that research for the good of local companies. And extending that work has allowed us to do more sensitive listening tests where we can reliably hear even small differences and know that they're not anecdotal opinions, that they're real. So that means that the measurements that we make come as a result of hearing something, whether it's hearing something that's better or worse, identifying what that is, and seeing how can we measure that characteristic now that we've proven that it's significant. So we all know, for example, that you can't compare two loudspeakers by putting them next to each other, because then they'll greatly influence each other's sound, and then neither will sound like they normally would. You can't have them very far apart at all, because they'll be influenced differently by the room modes, and so once again, below 400 hertz or so, you're back at square one. So it means that you have to have a position-independent listening, and so we have a facility that moves the loudspeaker into place and then switch it with another loudspeaker in about 3 or 4 seconds. And so that allows you to listen within the window of true aural memory, because of all our senses, our true memory of sound is very, very short. It's seconds long. So this allows us to have the most sensitive comparison of loudspeakers, and without this nuisance problem of the location causing a dependence problem. So we listen to things like, we were talking about other parts like crossover components, and it's my opinion that they have a very minor role in the sound quality, that if you're working towards a price range, that's not where you want to throw your money in most regards. And likewise in the enclosure, you learn that you can just be smart about how you brace the enclosure, that it doesn't take some magical unknown material, which generally costs a lot of money, and there's a lot of focus that some people put on those for enclosures, and it doesn't get you an acoustic improvement. We use a laser scanner to look at very, very minute movements of the enclosure. That is the most sensitive way to visualize what's happening, and found that MDF with appropriate bracing gives you as good a sonic result as you can get with some unobtainium material. So fortunately, there are ways to save money that have a very small negative effect on the sound quality.
So Richard, you mentioned before the challenge is bringing technology advancements down in price. So in this, you came out with the 7 a couple of years ago, then you've created the 5A, so now it's a 5A carbon. But still, those are expensive speakers at the top of your line. And you've just come out with the Trio, which is, what, about $6,000? What were the biggest challenges that you had in bringing the Trio to market and designing it so that you would extract the performance that you wanted to while still having a nice wood-clad speaker that would satisfy your customers and what they've come to expect?
Well, that was one of the simplest things I've done in the last 10 years. I just took the subwoofer out of the quattro. So, that wasn't hard to do, and it was a challenge to get decent bass out of that small of a volume, because I believe that bass is the foundation of music. Without bass, you don't have music. So we try to make sure that all of our products have a reasonable amount of bass to be faithful to the music. But our challenge in the future is to continue to work with this room management of energy in the bass without involving processing to all of the frequencies, because that makes it expensive. So we try to do that, after the fact, affecting the bass only. more than in the low frequency when you do it the way we are, and just continuing to try to get these balances between MDF and the different materials and bracing that Kevin mentioned, so that you can maintain a good, silent cabinet without and do it for less money. Basically, what I see we have to do for the next decade.
So Andrew, Kevin was talking a little bit about the laser interferometry. I can't ever pronounce it. Interferometer. Okay, I can't. But you come out of a pure research background in physics, and you've told me about the noise cancellation system on the smokestacks of big ships out in the North Sea or wherever it happened to be. How have you seen the change in the tools that you have available for the testing? Like you were talking about the diaphragm profile of the mid-range for the waveguide. I mean, you hear buzzwords. Some of the speaker manufacturers use COMSOL, which is a finite element program, computational fluid dynamics, a lot of really heavy computational development tools that didn't exist before outside the university setting because of the computational horsepower, but now people have that on their desk. How is that influencing you, if at all, and is it influencing on the driver design, on the cone profiles, on the actual magnet systems, or is it the cabinets, or is it the interaction, the diffraction that we talked about? Where do you focus those tools?
For me, maybe it's a bit different because I've always been in places where I've had access to those kinds of measurement tools. Most of the tools we have available are not new ideas. They're just available at a lower cost or to run on PC. But back in the mid and late 70s at KEF, we had the HP mainframe computers that were the Fourier analyzers that were on all the Polaris submarines. And they could do a full analysis of vibration of the cabinets. And we had tools, maybe not lasers, but we had capacitive measurement tools to be able to mechanically scan the cabinet, look at the vibration modes, do a modal fit to that. Same with measuring what cones we're doing. Measurement programs for looking at the impulse response of the loudspeaker. We were doing that in the late 70s. It wasn't easy, and everything was written in machine code. There wasn't a good graphical interface. So literally into the computer to make a measurement from 20 Hz to 20K, you do something like Y space 0, space 0, space 1, space 2, space 64, space 1, space 1. And that was the command. And you had to remember all these different kinds. I got good at typing those, even though I couldn't actually type. What we now have is on a PC for a couple $100, you can buy a lot of these measurement tools. Not so much finite element, but even that is more available now. But within the Pioneer group, we write all our own programs for doing this. We don't even go out and buy them. But without years of experience of knowing how to properly make those measurements and analyze the results, if you'll just buy for a few $100 a measurement program, you don't know what the limitations of how to measure are, and you often see artifacts that are more the result of misapplying the measurement technique than you are getting information about that speaker. So take just impulse response. Most people don't have an anechoic chamber. So the idea is, I don't need one. I've got an impulse, I can gate it, and I can cut it off before the first reflection comes. Well, that doesn't work because it's not a long enough measurement period to get a true representation of the, particularly the low frequency response. And if you've got high Q resonance, you won't see that either. So you've got to know how to find it, and that's when I feel fortunate because I'm back from my early days. I've had access to those facilities to be able to learn from them. So now that I can at least get them cheaply, I know what to do.
What's your favorite measurement tool or development tool that you have available to you at home?
You know, when I was in school, I remember a professor who said, you know, my best advice is always have smarter people around you. That's really my best measurement tool. You know, we have some.
So that was easy for you, wasn't it?
It was everywhere. So we have some incredibly bright people, and it makes me think of a gentleman that actually developed a new mathematical approach to designing waveguides that we're using in the Performance 3, but also extends to designing horns. And we're talking about possible breakthroughs. I'm giving you a preview that there is what is honestly a breakthrough coming out in horn design, the biggest thing in 30 or 40 years, that really look like they're going to make me convert to horns, which is quite impossible. But as far as a specific tool, you know, use ANSYS and COMSOL and all that. But it's more that, as you were saying, the people that know how to apply the tools and really understand. And that gets even more complicated when you talk about interactions with the room. And you know, I think of acusticians like Keith Yates' design group that takes vastly more sophisticated approach to that, and has always used fluid dynamics as the way of modeling the room. And anyone else is doing that whole room acoustics picture.
So Richard, I know one of your design tools has been your ears all along. And going back to the original experiments you guys did in the 70s to come up with the time and phase accurate model that you've stuck with. And you've told me that you're particularly sensitive to timing issues, and that's one of the reasons why in the balance you put in so high regard the first order crossover networks. Why don't you tell everybody, since you're the only one here who designs with first order crossovers, just why it was or what it is about that waveform recreation that you can get out of that that makes it so important and fundamental to your designs?
Well, on a note, what you were talking about earlier, in '77 I bought my first FFT analyzer. It was a Genrad 2512. The thing was $24,000. And you could buy a $200 program, probably less. You could probably get one free to do what that does in a computer. And but anyway, yeah, in our early development, we were trying to doing a lot of live burst recording, and we still do that. That's how we and getting involved with forensic medicine and everything. It turns out that in my opinion, the human being is more a timing device than an amplitude device, and it's so I believe very early on, those early experiments showed us, although it was subtle, it's not the only important parameter of a loudspeaker. That realism to where you can just sit there and think, wow, that sounds like that piano was in the room, was enhanced to differing degrees when that waveform could be replicated that was originally captured by the microphone. Most microphones, or all microphones, panels, most everything in the chain is time and phase correct in our world today, and even in the old days when there were making recordings, the only difference was what was the bandwidth. The bandwidth has changed. But it was just, I was just particularly sensitive to maintaining that type of pressure wave that an instrument would produce in this space here, and trying to preserve as much of that as possible. Yeah, in the final analysis, there's a lot of ways to skin a cat. And what you hope is you come up with this, you perfect it, you put your heart and soul in it, and hope to hell enough people agree to keep you in business.
Andrew, one of the things that, you know, just for all of you, I mean, the two rooms that I've been to already this morning to listen to, you go to Andrew's room and you go to Richard's room, and, you know, the sound is phenomenal. And the thing that's interesting, Richard always has very consistent products in his demonstrations, whether it's here, whether it's CES, whether it's Rocky Mountain, and he always gets a really high quality sound because of that consistency. It's not just the speakers, but it's the whole system. And Andrew, I know we've talked about the fact that you've always, in your designs, tried to be able to have it sound good regardless of the high quality system that comes in front of it. But why don't you just talk a little bit about how your design approach for your speakers matches your setup approach for show conditions so that you can show people who are coming through what capabilities your speakers actually have. Because I think that's an interesting element, and it kind of goes to the design itself, of how you're interacting with what comes before and then the room that the speakers are engaging.
Let me just sort of say, the only reason you didn't mention Kevin is Kevin doesn't have a room here. Otherwise, I'm saying the three of us have the best sounds.
Well, I said the rooms that I've been in too, so that was my excuse. I hadn't been in California.
Yeah, you know, I think the key, particularly these days with the way the market has gone for dealers, access to being able to hear a range of equipment. There's very much fewer dealers around now, independent ones, with enough range of equipment for you to be able to walk in and spend the time and go, oh, I'd like to hear that source with that preamp, that power, that speakers, that cable. The shows, there's more shows now, they're the way for people to winnow down and find out what they might be interested in. So I think it's incumbent on all of us to know how to give a good demo, and part of that is the room. We've all been talking about interface with the room. It's both from the point of view of how you design the speaker to best work with rooms, whether it's mid and high frequencies and directed control, or whether it's the low frequencies and how it interacts. But kind of work on the room to make sure you can give a good demo. And I find a lot of rooms are not treated, and I've been in some, not at this show, but in other countries, I've been in some god-awful rooms that sound like caverns. And it seems that people think, oh, you can listen through that. And it may be a misguided way of saying, oh, people in their homes can't necessarily treat the rooms to get the best sound. But the room is such an integral part of a loudspeaker. A loudspeaker doesn't exist without the room that it's in. If you listen to a loudspeaker outdoors or in an anechoic chamber, it's horrible. You do need a room to give back some of that sound, but it has to do it in the right way. And if you don't treat the room, if you don't position the speaker correctly, or use whatever techniques are coming around to help interface into the room, you're not going to get a good demonstration. And I think it's important that we do that and give an entertaining demo, choose the right music. You know, the music, it is about the music, but you want to choose music that both shows off the capabilities of the speaker, but also is musically interesting so people enjoy sitting down and listening. They're not sat there thinking, oh, not this piece of music again, or I'll play the next piece, I don't like this. So you've got to try and work that into the way you demonstrate.
So, Kevin, you mentioned that you may be returning to horns.
Well, I was never there before.
Oh, you never
Not really.
but my question, I guess, and then I'll ask all of you this, is if you had a perfect world, right? And you had an unlimited budget, and you had all the smart guys around you that you could bring together, what would your perfect speaker have that you maybe don't have now, or just have more of it that you don't have now?
It would certainly be active. And the only reason that we don't make active speakers right now is that people are voting with their pocketbook. Audiophiles just don't like active speakers in general. And there hasn't been anybody that's come along and created an example that might really counter that and blaze the path. But my ultimate speaker would have to be active. We can do an awful lot through transducer design and through passive filter design to get things right, but still more effective if it's active. And then you could also design transducers that potentially could ignore their amplitude response in favor of other characteristics because the amplitude response would be trivial to fix with DSP EQ. So I think, as Richard said, that the room is inextricably linked with the loudspeaker, and below about 400 hertz, the room's actually more important than the loudspeaker. So what do you do to solve that problem? Well, the right thing to do, and certainly my ultimate speaker would have 4 subs in the corners. We spent a lot of money doing the research and published it for the world to see. That if you do that, you've eliminated half the modal problems, and the seat-to-seat uniformity, if you don't sit all alone in one seat all the time, is drastically improved. And then we've got some algorithms that further reduce that variation, and use auto EQ to really get things right at the listener's ears.
So piggybacking on that active concept and the bass, so Richard, from the Quattro on up, the Quattro, the 5, and the 7, they all have an active subwoofer component along with an analog equalization, multi-band equalization system. So is the active bass to take advantage of the kind of optimized amplification for the driver so that whole system works, or is it really, have you done that as part of the process to have that bass adjustment that you were talking about?
Well, I mean, if I could afford to, I'd have every speaker we make be amplified in the bass with the high pass the way we do, and that way any processing that you do to correct for the room doesn't require any kind of digital DSP or any kind of digital manipulation of your mids and highs. There's a lot of people that are still pretty pro-analog, spinning vinyl and everything, and don't want anything digital in their signal path. So the reason we took our path was to just stay away from that issue because it's still pretty strong today. But there's so many things you can do when you know the driver, you know the enclosure, that you can reverse engineer into the amplifier on board that like Kevin said, an amplified speaker has a lot of advantages, but the biggest advantage would be in the bass, and that's why we put it in as many products as we can afford to do that. However, the automatic adjustments and everything, we've had great difficulty with. We spent a lot of time and money trying to find a way to automate that, and the problem is you don't change anything at all. You do the test, you're sitting in the same chair, you do the test 5 minutes later, and you get a totally different answer every time. And that's because that test is so easily corrupted. There's nothing like a human being looking at a needle on a sound pressure meter, interpolating exactly what that reading really is. And any type of sampling circuit has to, at some point, sum those samples, no matter how fast you reset it. You have a sum of samples that's easily corrupted, especially in the low frequencies, because you can't get your environment perfectly silent. And it's certainly better than nothing. But we've preferred to do it more manually in the analog domain, just because the results were more predictable. But I agree with Kevin, an amplified speaker would really be the best of both worlds, except that it would be a marketing issue just because there are people that prefer, I mean, over the years, I do a lot of traveling all over the world, and I've heard systems with my speakers in them in many, many places. And I'm always amazed how different they can sound, and not just because of the room, it's the selection that people have made with the associated equipment. So here they like, so I get calls all the time, what's the best amplifier for my loudspeaker? And I said, for me or for you? Well, you're the designer, you ought to know. There's, within the same loudspeaker, if it's reasonably neutral, the sound can vary so much. And the people that are in the worst situation, in my opinion, are those that are unfortunate enough to have dedicated sound rooms. These are always the worst sounding rooms because they're not properly treated. There isn't someone in the house that's decorated and caused a lot of natural diffusion. Rooms that tend to sound best are rooms that you live in, because if it was an echo chamber, you wouldn't want to live there for long. kind of naturally, now that can obviously be done in a dedicated sound room too, it's just often overlooked. And in some cases, people tend to use so much absorption that you kill the dynamics of the room, where diffusion is the right way to do it, and at least in most cases. So,
So Andrew, what, if we were now 5, 10 years from now, what would you have hoped would be achieved between now and then?
Retirement. I love my business. I'm never going to retire. You know, it's a lot of what these guys were saying. I keep sitting here thinking, next year I'm going to sit there. So it's always, well, as Andrew said, it's as Richard said.
you want to change places?
As we all said, first let's pick up on the active thing, because when I started the TAD project, my thoughts were I'm going to design an active system. But there's several things that work against that. As an engineer, that's the way you want to do it, but first of all, you realise in the marketplace, active has never really succeeded, just because everybody wants to pick and choose their electronics. And as Richard said, your speakers sound different with different electronics. But there's another aspect of, there's a simplistic way of looking at active speakers. A few watt amps, and I've built some active filters, and I've got some amplifiers. But when you look at what we are spending as perhaps ludicrous amounts of money on a preamp or a power amplifier, now you have to triple that up if you do a 3-way active speaker. If you think that just a line stage preamplifier needs to cost $42,000, and I say that because I have a line stage preamplifier that costs $42,000. To turn that into an active filter, you know, a good quality active filter, if you believe in the power supplies and the circuit topology you need to just do a line stage, then you're going to turn that into a filter. But now you need filters in cascade and in parallel to do a full active thing. Are you going to spend $200,000 on that active crossover? There's some cost savings when you put it all into one case, one power supply, but you still, I think, okay, so active done to that level maybe is not so cost effective. Where do you save, or how do you balance between the gains to be had from going active versus the costs, you know, with 3 times power? So I haven't still resolved in my own mind that question, but by having now gone from not just doing the speakers, but doing the electronics, we get to the point that we'll also discuss about equipment sounding differently. At least, if I have a philosophy of what sound I want to achieve, by having my own electronics that, no, I don't directly design the electronics, I design the speakers, but not the electronics. But I oversee the development so that I can make sure it meets my objective of what I want to sound like. Then at least when I do a demonstration, I know I'm fully giving you a representation of what I want you to hear, and it's consistent to a greater degree around the world, save for the room that's chosen to exhibit it. And that can be, like I said, dire sometimes. I was given a cavern. It was a concrete floor, concrete ceiling, concrete walls, no windows, second floor down in the basement. And this was Milan, and I walked in, I thought, I'm never going to pull this off. I'm never going to get a good demonstration in there. How can I find enough absorbent at the last minute to fix it? I woke up literally in the middle of the night on my bed going, mattresses, sir. It's a hotel room. There's 100 mattresses somewhere. So I went down to the front desk the next morning and can I have a dozen mattresses? And I put them around the room, and then how do I cover them? IKEA. I always go to IKEA in every country I've visited. And this was Italy. And they had mattress covers in black. Because it's Italy. It's cool to have black mattresses. It looked professional. It looks like it was 6 inches deep rainbow fits on
I think it's all of us.
No, what I said I was going to do, all the hotel shows in future, I'm going to book with the hotel management and own all those mattresses. Then I'm going to rent them out to you.
that shows for very many years used mattresses at one time to deal with a roof.
So one last question about design. Is there a piece of music, an album, sound effect, is there something that you go back to again and again and again that you hone in on and you just know inside out, and it's your personal reference when you are making sure that what you think is working is in fact working? Do you want to start, Kevin?
Sure. There are about 40 tracks that I listen to little bits of whenever there's a change that we're listening to or whatever. But if I was going to pick one thing that's a torture test, of course it's a vocal, because it's just the hardest thing to fool us on. And male vocals are the hardest thing to reproduce because they can potentially go low and particularly go down to the range that's really hard to measure, especially without an anechoic chamber if you're comparing against competitors. So it's Joe Williams, Dollar for a Dime. It's been around for a long time, and nothing's come close to being as challenging, I found, for loudspeakers to sound real on.
Andrew, is there some track?
Vocal and male, but I use female and male vocal, but what you said about male vocal is right, because of the expanded range downwards, it's a very good indicator, particularly interfacing into the room, because it starts to affect that chest region. So my go-to track is the Lost Gags that I always play my time. And yeah, there's lots of tracks. You get into the habit of listening to a bit of the track and forgetting what the end of it sounds like. And then you get to a show and you leave it running because you're distracted and you go, oh, I wonder what that one is. Oh, it's the one I normally play. But the music has to be interesting. As an evaluative tool, it's good. As an illustrative tool, it has to be interesting so that anyone who comes into the room can stand to listen to it and enjoy it. And then we've got to enjoy it because we're listening to it day in, day out, the way things go.
Richard, your favorite?
I use my own master tapes that I made exclusively when I'm doing development. I was there when the recording was made. We used a pair of our speakers for monitor. Made really accurate notes as to what was going on in that church for that 2 weeks in a row. Involved female, male guitar, piano, drums, stand-up bass, saxophone, a wide variety of instruments, and got very familiar with that acoustic space. And that's pretty much all I use. Obviously, a designer is never really through critiquing his work. I wish I could get half the sound here out of a given system that I get in my own home. But I've been working on that room for 19 years. You get very, very familiar, and then you can hear the differences.
Great. Well, we need to clear out so that the next group can come in. But I want to thank everybody.